Hey, this is Lee, and welcome to our online class for organic chemistry. So, class, I know if you can still remember, we have already discussed about the aromatic reaction. So, I will just add some information about it. But before anything else, let's just recap our previous discussion. It will be different processes under the aromatic reaction. So, as I have told you, you have to familiarize the different reaction here with their catalyst, the products, and the electrophiles. So we have the halogenation, nitration, sulfonation, and for the Friedel-Crafts, we have the alkylation and acylation. So browse your notes. I have already sent to you this document. So while I am discussing, please check it and make some notes as well. So the additional notes I'm going to give you regarding aromatic reaction is this one, the effects of substituents. So substituents can actually affect the reactivity of the aromatic ring and as well as the orientation of the reaction. So guys, may maririnig kayong mga background noises dito kasi nasa bahay na ako. So just bear with me, okay? So let's go back to our lesson. Substituents affect the reactivity of the aromatic ring. Substitution can result in an aromatic ring with higher or a lower reactivity. So as you can see sa ating screen, ang part na to, ang structure na to, it shows the reactivity of the different benzene ring with its own substituents. And nakikita nyo si phenol, higher ang kanyang reactivity sa benzene ring, while the chlorobenzene and the nitrobenzene has lower reactivity than your benzene ring. Okay? So, ganun lang yun. Ang mga substituents, they affect the reactivity of the aromatic ring. Now, let's proceed to the substituents that affect the orientation of the reaction. And this is commonly found sa mga dye-substituted products. And sabi ko, in our naming for dye-substituted products, we are using this system, the Ortho, Meta, and the Para naming system. And si Ortho, Meta, Para daw, they are not formed in equal amounts. Okay? Makita niyo mamaya yung percentage ng kanilang product mamaya sa picture na to. And listen, importante to, the nature of substituent initially present on benzene ring determines the position of the second substituent. So let's say we already have a benzene ring with a substituent. So yung substituent na yun yung magbibigay sa atin ng idea kung ano yung possible orientation ng ating dye-substituted product. And to guide you on how to predict the product, we have this table here. This one, you should write this sa index card para parating nyo siyang mababasa at mas ma-familiarize nyo siya at mas madaling mag-study pag nasa index card siya. So we have the meta directing the activators. Yan. So lahat ng ito ay mga functional groups. So dapat alam nyo na ang mga pangalan nila. Like for example, we have the CHO, meaning that's an aldehyde. And then ito, may COR. So that's a ketone, di ba? R-core, ketone. So dapat alam niyo na yan. And also, we have an ortho and para directing deactivators. Ito naman, easily lang siya ma-memorize kasi lahat ng nasa ortho and para directing deactivators, as you can see and observe, they are our halogens. And we also have the ortho and para directing activators. Yan sila. Ito yung mga ortho and para directing activators. Kaya take note, etong halogens are the activators, ito naman ang activators. So, for now, i-disregard nyo muna itong mga deactivators and activators. We will have a different discussion regarding this. But ngayon, gusto ko mag-focus kayo sa ortho and para directing, and then itong mga meta-directing. So, sabi ko, your initial substituent will help us predict kung ano yung dye-substituted product natin at kung saan natin ikakabit ang second substituent natin. So, to help you visualize it, I have an example here. Yan. Okay. Check natin. So, let's say, ito yung reaction natin. Ang benzene, ang initial substituent na ating benzene is the chlorine. So, i-check nyo ngayon kung saan belong si chlorine. Is it a meta-directing, ortho and para-directing, or an ortho and para-directing? So, kung titingnan natin ang ating table dito sa kabila, makikita natin na si Cl ay under sa ortho and para-directing deactivators. Therefore, ang product nito can only be an ortho or a para na structure. And since one of its reactant is a bromine, therefore, the reaction is known to be as bromination. So, ang madadagdagan na second substituent sa ating benzene ring will be the Br. Yes, the Br. So, ano kaya ang pwedeng product natin? Again, the product should be an ortho and a para-directing na structure. So, the possible product is like this. Yan. Ayan. So, again, our initial substituent is the chlorine, which is an ortho and para-directing deactivator, and our reaction is bromination. Kaya ang second substituent na madadagdagan sa benzene ring is our bromine in ortho or para position. So, the major product for this reaction will be ganitong itsura. So, we have the bromochlorobenzene or the para-bromochlorobenzene. Ortho and the para. So, ganyan lang siya, guys. Okay? Do not forget that, okay? So, since I have already shown you kung paano gamitin tong mga meta-directing deactivators and ortho and para-directing deactivators and ortho and para-directing activators, let's proceed kung ano nga ba ang ibig sabihin ng mga activators na to at deactivators na to. So it's another concept. So pag sinabi natin activating or deactivating, ang meaning lang niyan guys is their reactivity. So for activating groups, ito yung kanilang mga characteristic. For activating groups, the ring possesses more electrons. The carbocation intermediate is stabilized and the action energy is lowered. So pag sinabi natin activating, more stable siya, mas maraming electron. And lowered ang activation energy. So activation energy, kung ma-remember natin sa inorganic chemistry, it's the energy that we need to surpass for a reaction to occur. So since mababa lang ang kanyang activation energy, then masabi natin mas madali siyang mag-react or mas mabilis ang reaction. So yun lang yun siya guys. Kaya ang tawag sa kanya ay activating. Ang deactivating naman ay just the opposite of the activating groups. So in sa lahat ng mga functional groups na nandito, ang activators lang ay etong mga to. Okay. But we also have here the complete list ng functional groups and substituents and their reactivity. So yan. Yan sila, okay? Ito yung mga functional groups natin or mga substituents and their reactivity. As you can see, etong nasa dulo, this one is an amine. Because a benzene with an amine group is called as an aniline. So, ganun lang din. Pag ang CH3, nilagay mo sa isang benzene ring, ang tawag dyan ay toluene. So, ganun lang guys ha. Dapat alam nyo yung mga functional groups na nandito. So, let's say for example, ito, we have the COCH3. So, that's our core. That means it's a ketone group. Well, this one is arco-or. So, pag arco-or, ester. So, is CHO, CHO, that means it's an aldehyde. So, ganun lang ang ating ganun lang inyong kailangang i-memorize. Yun lang. Yung mga yun lang. So, dapat alam nyo yan. Alam nyo yung mga formula ng ating functional groups. So since you already know the reactivity, so just refer to this. Now try to answer ito, number 1 and number 2. So since this is an online class, I need you to pass your answer online din. So the first one who can pass their answer at correct will have an additional grade or additional points for me. So the number 1 item is to predict the major product for nitration. Nitration. So i-check the process of nitration. Kung ano ang dapat madagdagan sa benzene ring. And again, you should predict if it's kung ano ang posisyon ng second substituent by looking at the initial substituent na nakakabit sa benzene niya. Then the second one is just to rank the compounds in order of their reactivity. So, para maging uniform tayo, you need to use the greater than sign to show the rank from high to low reactivity. So, yun lang. Muna, you have to answer that first.